Hi, welcome to a product review by watthour. In this video we are going to do the review of this active cell balancer for up to 8 or 12 cells for lithium ion and lithium iron phosphate batteries. I'm going to explain how this functions, show you how to do the wiring, and also we're going to test it practically and measure the current and voltages. Let's get started with this. And these are the brackets. And here I have now 3 cells ready for ground, and monitor the top cell. The current is being drained from this cell. In many websites they have anti-set with the resistor here. Now for this cell, this is 3.6, so this is very high, 3.61. Wiring for the 4 cell, the first cell is connected, and then yellow is to the other side of the same battery. The cell 1, 400 milliampere. Let's check it after 40 minutes, 61 degrees Celsius. I burned this 4 cell power supply that it will not allow more than 1 ampere. I have separate video explained this battery management system. The link for that is below the video in the description. Also, I have separate video explained and tested this cell balancer. This is passive, just resistive cell balancer. The link for that is also below the video in the description. This is active cell balancer. So the difference between passive and active cell balancer is that this is not wasting energy. This is supposed to be 92% efficient, and it just checks the balance, the voltages between each cell, and if one is high, the other is low, it drains it into the other one without wasting much energy. About 8% will be wasted, the rest will be transferred. So this way it's very efficient. Less heat is dissipated here, and this can handle up to 2 ampere. This can be programmed from 100 milliampere, and up to 2 ampere can be programmed, but this is labeled as 1.2 ampere on AliExpress, eBay, and Amazon. But these are resistive. What it means is instead of transferring energy between cells, it burns it here as heat. We have high power resistors here, and they will heat up and drain that specific cell until it is at a certain level. This is wasting the energy as heat and the resistor, but the active one, this is inductive. It has inductor and back converter, and takes the high voltage from one and charges the other cell until both cells are equal, and it will stop. So why we need to balance a battery? Due to chemistry or many other reasons, when you use a battery, when you, for example, discharge it or use it, some of the cells might discharge more and some of them less, and the voltages will be high and low, and this will cause the capacity to be reduced, because when you're draining it, your device that is monitoring it, it will stop the usage of the battery at certain value, and some cell will have higher voltage, some low, and the capacity will be there, but you will not see it, so the capacity will be reduced. Also, when you keep the voltages consistent between all the cells, the battery will be healthy, and the charge cycle will increase, and the life of the battery will be increased. So you have 2 important benefits. Life of the battery will be increased, and also the capacity will be consistent, and you have maximum capacity. Another advantage for this one is that you can leave it on your battery and charge your battery. This will not have any bad impact. It will just keep the batteries balanced while charging. So this can be used while the battery is connected to the charger and while it is not connected to the charger. This cell balancer is sold on AliExpress, Amazon, and other stores. For example, this is $3 with $6 shipping. 4 cell, the price increases. 5 cell, 6, and as you can see, we can see it's sold up to 24 cells. So depending on your application, you can get different number of cells and different prices, but they've labeled them all as 1.2 ampere. I will provide you affiliated link, so you purchase and also I get some commission from it. The link is below the video in the description. It's a cell balancer, and we are going to test it. For 3 cell we have 4 wires. For 4 cell we have 5 wires. So for each cell we have 1 wire, and there is 1 for ground. And this is for 3 cell, 1 wire is for ground, and it starts with a first cell, second and third cell. And this starts with ground, first, second, third, and fourth. And I wish they had used different color for each cell continuously, so it should have been consistent. But as you can see, they are not. So they use for the first cell here green, and here they used yellow. We have an inductor here. We have a switching frequency. We have a chip that checks the voltage, and between the cells it moves the current from one cell to the other cell. So the amount of voltage is being reduced and the current is being drained to the next one. So this has LEDs here, 1 to 2, 2 to 3, and 3 to 4 cell will be turned on. And also in this one, when you use it for the 3 cell, it says between 1 to 2, 1 light will turn on, and between 2 to 3. Very advanced and very efficient, 92% efficiency. And once you attach it to your battery system, this will consume only 2 microampere. So this is so much minimal that we can say almost zero, because in the long run, if you leave the battery on the shelf, so this will consume very little current and you can leave it all the time connected. Now let me explain how the balancing happens. We must have 2 or more cells, and one chip can monitor 2 cells. 2 cells are connected like that, and we have top, and then we have common, and this is the bottom wire. So when we monitor the top cell, this is how it is done. At these 2 points the voltage is being monitored, and then for the bottom we monitor the voltage like this, to this pin and to this pin. And here, when the bottom voltage is, for example, 4.1 and the top is 3.9, then bottom voltage is greater than top. In this case, we need to reduce this and fill the other one up. So this is what happens. The current is being drained from this cell to the other cell until the voltage of that cell is equal to the bottom cell, and it will stop. And if it is the opposite, when the top cell is, for example, 4 volts and the bottom cell is 3.9, in this case V top, or top voltage, is top cell is greater than bottom, then in this case we will drain the current to this cell. So this chip is taking care of this until this voltage is equal to the bottom cell. So top and bottom, when they become equal, then the current pouring or charging the bottom cell will stop. And here, if you want to monitor, for example, 4 cells, then we need 3 chips. One chip can monitor these 2 cells, and then this also should monitor 2 cells, and this will monitor 2 cells. So the cells will be common, and that's why we need 3 chips between 4 cells. As you can see, we don't have any Zener diode or anything. When I was searching online, I found this diagram, have been shared in many websites. They have added this MOSFET and this Zener diode. Also, this is for the exact same module, ETA3000, and there is no Zener diode or anything. So, and here I found this diagram as well, based on ETA3000. Exact same configuration, no Zener diode or anything. We just need to connect our cell between these points and these points. So we have U1, U2, 3, 4, 5, and 6. So this is for 6 cells. On some diagrams on AliExpress, they are showing this 100 ampere hour battery. They use these tiny modules with this 100 ampere hour cells. You see, for this one, this is 100 ampere hour, and this chip can discharge only at 1 ampere based on the setting that I saw. This is 1 ampere. So this is just joke, because if there is unbalancing between the cells, it will take 10 hours, 20 hours to just fix it, because this is 100 ampere hour. So with a little fixing with 1 ampere hour, so these are all just joke. They just made these photos. They're impractical. Video on this 5 ampere balancing, at least balance between cells at 5 ampere current, which is reasonable to fix them maybe in 5 hours, 10 hours, balance them. And here is a data sheet for ETA3000 inductive cell IC balancing up to 2 ampere. Efficiency is 92% and low sleeping supply current, which means if you connect it for a long time, it will just consume 2 microampere, so which is very minimal. One chip can balance 2 cells. Beside the other components, which has an LED, will turn on the state of balancing. It needs an inductor to operate because this has a switching power supply. And the most important part is this 1 microfarad and resistor, IR resistor, the resistor that you set the amount of current. In terms of package, they are offered in 2 packages, SOT236L and DFNX 2X8L. So one is 6 pin, the other one is 8. Here the packages, so we have 6 pin and we have 8 pins. I'll provide you the data sheet for this if you want to have a look at this. And here is a chart to set the current. The current is set with the resistor here, and it starts from 100 milliampere and maximum to 2000 milliampere or 2 ampere. Lowest resistance is 500 kilo ohm and maximum is 25 kilo ohm. So the smaller resistor will result in higher current. Then IC capacitor is the same, 500 picofarad to 10 nanofarad. It does not change, but the inductor changes. As you can see, from 0.33 it goes to 1 to 2 microhenry. So what it means is it's not that critical. Go 1 to 2 microhenry, and the battery capacitor 0.47 to 3.3 microfarad. For the 3 cell and 4 cell, I'm going to put this 3 cell under the magnifier. So the first component that we see here, these 2 Schottky diode, I believe. Let's check it. We are unable to read it, but here it says AE. So this shows for cell 1 and 2. This is for 2 and 3. So this is the main chip. Oh, this is so bad. I put so much paint, but I believe we can read it. Or maybe the next one. Let's see if we can read it here. This is 2000 ohm, and that's 51 kilo. And from this programming table that you see, for the lowest current we need 500 kilo ohm. For the maximum current 25. So there is no 2.2. This is not the 2 kilo ohm because we don't have any 2 kilo ohm here, but this is the right one. That let me show you from this side. The one that says 513, 5 and then 1, the 3 means 30, 51 kilo ohm. For 50 kilo ohm, we can get 1 ampere. And if we reduce it to 40 kilo ohm, we can get 1.2. And if you want maximum current of 2 ampere, then we need 25 kilo ohm resistor. So just replace this resistor with 25 kilo ohm and you get 2 ampere. I burned this piece here. Let's see what happens. So yeah, as you can see, this piece is burned. This is the same piece as what we have here, AE only. And here I have these 4 18650 lithium batteries, and these are the brackets. I'm going to prepare them. So first let's put the positive on the first one, and I put the terminal facing this way. Then I'm going to put the negative. So this, put the terminal facing this way. Then I'm going to put the negative. So this again positive, this red facing this way, and positive, negative, and then one more negative at the end. Lifting the terminals up. This is in and that's out the flat side. Now I'm going to solder this. So leave, for example, the positive, and then this will be connected positive to negative. On this side I will solder it like this, and then this positive will be soldered like this, and then I have positive and negative will be soldered here. At the end I will have one positive, one negative, which are the 2 terminals. And here I have now 3 cell ready with this type of connector, and also 4 cell ready. We're going to test it. We're going to attach it to these pens. And this is a simple voltmeter. They are very precise. I've checked them. Let me show you the voltage for this 4 cell, for example. Let's check each cell. I'm going to connect the negative to one side. This is negative for this, but positive for that one. So I'm going to put it on this side so we can read the voltage. As you can see, this shows 3.48 or 3.549 volts. I check that side. If I check this one, 3.49, that's correct. And now for this cell, this is 3.6. So this is very high, 3.61. And the last cell, 3.48. So all these 3 cells are the same except this one. So let me show you the voltages for this 3 cell. So it's 3.87, the first cell. The second cell 3.46, and the third cell is 3.75. As you can see, this is not balanced, so we are going to test this as well. And here is the wiring for 3 cell. The first cell is connected from the negative to the first wire on this side, and then the positive goes to the next one. From the positive of the second cell it goes to the third one, and from positive of the third cell goes to the last one. So it has been labeled as battery B3 plus and B minus. So B3 means cell 3 at this point. Here I've soldered this. The first wire, the black, is on the first cell, and then yellow is to the other side of the same battery, and then white is coming here to the other side because these are in series like that, and orange is connected here at the end. And as you can see, now it's showing that it's being balanced, but I have to show you the current. When the cell is being balanced, you should see current between the wires because there is no charge or nothing. External power is not connected. So let's measure the current. I'm going to set this to 0. Let me turn on. So let's see the cell 1. 400 milliampere, so it's being balanced. Cell 2, 1.3, that's huge. Current is being, this is positive, so it's coming from here and going to the other one. This is 3.7, this last cell, and Let's check the second cell. That's 3.4. So this has lower voltage, this has higher. Now this is pouring current into this, to the middle cell, to fill it up. This is heating up slowly. This got warmer. Now after a few minutes, again let's check it. First cell, 1.2 ampere. Second cell, 1.3 ampere. And last cell, 0.6. Pay attention, the last cell is negative. So maximum 1.5 ampere, this can balance. So for the larger battery capacity, you need different type or more powerful balancer. So after 30 minutes, let's check the first cell, 700 milliampere negative. So this is absorbing. Second cell, 700, that is emitting or giving. And this is minus 500 milliampere, so that's absorbing. This is the last cell, 3.66. So second cell is also getting balanced, 3.5, 3.6, 3.59, this is 3.6. It's getting 3.69, so it is being lowered. The voltage for this is high. While I was soldering the fourth one, it seems that I burned it because some of the wires touched incorrectly and it was live. So this is now dead. I'm using this Seek thermal camera. The link for the camera is below the video. 62 degrees. And now let's check it after 40 minutes. 150, 120 milliampere. The second cell, 300 milliampere. And the third cell, 160 milliampere. So this has not been balanced yet. And here, after some times, when I lifted and I came back, the lights are off, which means the battery is fully balanced. Now let's check it with the same meter that we did before. So this is 3.66 or 3.67. The second cell, 3.6. So 60 millivolts difference. Now I'm connecting this ammeter as this type of connection. If I put the polarity correctly, it will show positive, but if I reverse the polarity of these wires, it will show negative. So I'm gonna pay attention to that. I'm connecting the second cell, disconnecting the wire, and the second cell is measuring between these 2 points. So this point for the second cell is positive. Okay, and for the third cell. So let me put it here, and then let's connect this to this terminal. Let's just connect this. As you can see, this turns on and it shows that this battery is losing the current, 170 milliampere, because it's negative, so it's being drained. The last one, 3.66. So the middle has been not fully balanced. .61. Maybe that battery has different characteristics, or it was not possible, but At the moment the current is 0 because the lights are off. Now I can connect it with 3 cell to charge the battery and connect the balancer or for the 4 cell. Because I burned this 4 cell, I'm going to connect this 3 cell and I'm going to connect the 4 cell charging, but the battery will be connected only to the 3 of them and will take care of the 3 only. My current meter, let me show you the limit. First, let me show you the voltage for my power supply. 16.8 volts for the 4 cells. I've set the current, if I short circuit it will allow only 1 ampere. So I've set it with my constant power supply that it will not allow more than 1 ampere. So this is 1014 milliampere. The battery is being charged with 1 ampere, but it's unbalanced. What it means is that some cell might get less, some of them can get more depending on their chemistry or depending how much charge they had before. So when I connect this, you can see that it's taking care of 1 cell at the moment. This was a review of the cell balancer. If you learned something and found this useful, please thumb up, post your comment below the video, and also don't forget to subscribe. We are going to have a look at this Smart Universal LCD Fast Charger by LiFePO4. This is LiFePO4, and there are so many variations of this is sold, and it says 2 ampere fast charging for 4 lithium battery for different sizes. I'm going to measure the efficiency when I'm connecting it from external power. This is when you're connecting it with 12 volts. And I'm going to measure the current for each cell when you're charging it, so we see is it really supplying 2 ampere, 1 ampere and 500 milliampere or not. 44%, and there is a good connector here. Backlight first. So this is high efficiency offline constant current, constant voltage. Website watthour.ca.